Have you ever felt like your brand new phone is already slowing down, or that your laptop is just deliberately making you wait? Well, it's not your fault, and it's definitely not a mystery. It all comes down to two key parts inside your tech working in this kind of delicate dance. Today, we're going to pull back the curtain and go deep inside your devices to show you what's really going on so you can unlock their true power. Oh, we've all been there, right? That moment of pure frustration when your game stutters at the worst possible time, or that video you're trying to watch just starts buffering again. What if I told you this isn't just random bad luck? It's a puzzle we can actually understand, and all the clues are right inside our machines. And the answer? Well, it's hiding in plain sight. It all comes down to two things: the CPU, which is literally the brain of your device, and the memory, which is its short-term workspace. You can think of them as this lightning-fast duo. When they work together perfectly, everything is just smooth and seamless. But when they don't, well, that's when you get that soul-crushing lag. So let's start with the brain of the whole operation, the CPU, the central processing unit. Every single thing you do, from a simple click to editing a complex video, it all gets processed right here. It's the engine that makes everything go. So what does a CPU actually do? Well, it follows this simple but incredibly fast three-step process. It fetches an instruction from memory, it decodes what that instruction means, and then it executes it. This whole cycle, fetch, decode, execute, happens billions of times every single second. It's literally the heartbeat of your computer. But here's the thing, not all CPUs are created equal. So what makes one faster than another? Well, it really boils down to four key things: how many cores it has, what its clock speed is, the size of its cache, and its processor type. So let's break each of these down. All right, let's dive into these four keys to speed, and we're going to start with the one that's all about doing a million things at once: multitasking. I want you to imagine a chef in a kitchen. A single-core CPU is like one chef frantically trying to chop vegetables, stir a pot, and plate a dish all at the same time. Now, a multi-core CPU, that's like having a whole team of chefs, each one working on a different task. The more cores you have, the more you can juggle at once without everything grinding to a halt. It's why your phone can run social media, music, and maps all at the same time. And there's a really fascinating reason we even have multi-core processors. As the legendary ARM processor designer Steve Ferber points out, engineers basically hit a wall. They couldn't just keep making single cores faster because they were getting way too hot. So the solution wasn't to go faster, but to go wider by adding more cores. And that simple shift changed everything. Okay, on to our second key ingredient, clock speed. You've definitely seen this on a spec sheet, right? Something like 2 gigahertz or GHz. But what on earth does that number actually mean for how fast your computer feels? Clock speed is basically the rhythm or the pulse of the CPU. A 2 gigahertz CPU completes 2 billion of those fetch, decode, execute cycles every single second. I mean, just think about that, 2 billion. It's absolutely mind-boggling. So while having more cores lets you do more things at once, a higher clock speed means each of those cores works much, much faster on whatever task it's been given. Our third factor is something called cache. Let's go back to our chef in the kitchen for a second. Instead of running to the big pantry across the room for every single ingredient, a smart chef keeps the most important stuff, salt, oil, spices, right there on the countertop. That's exactly what cache is. It's a tiny, super fast little bit of memory right on the CPU that holds the data it's going to need again soon, so it doesn't waste precious time going to fetch it. And just like in a kitchen, there's a hierarchy. You've got L1 cache, which is the smallest and fastest. That's the salt and pepper right by the stove. Then you have L2 and L3, which are a bit bigger and a little further away, kind of like a spice rack. The bottom line is, the more cache a CPU has, the more efficient it is, period. And finally, our fourth key is the processor type. There are two main philosophies here. On one side, you have CSC processors, which you'll find in desktops and laptops. These are absolute powerhouses, designed to handle really complex instructions. On the other side, you have RISC processors, which are in our phones and tablets. These are all about efficiency. They use fewer, simpler instructions, which means they use less power and create less heat. This is what allows for that system-on-a-chip design, where the CPU, graphics, and everything else can live together on one tiny, cool, and efficient chip. Okay, so we've met the brain. But a brain, no matter how powerful, is pretty useless without memory. So now, let's talk about the digital workspace where all the action really happens. And just like with the CPU's cache, there's a whole hierarchy to memory. The rule is actually really simple. The closer the memory is to the CPU, the faster it is. But, and there's always a but, it's also much smaller and way more expensive. It's a constant trade-off between speed, size, and cost. Now, when most people say memory, what they're really talking about is RAM. And the best way to think about RAM is like your computer's desk. When you open an app or a file, you're basically putting it on the desk so you can work with it easily. But here's the crucial part. RAM is volatile. That means when you turn the power off, poof, the entire desk gets wiped clean. Now, RAM comes in two main flavors. What we use for our main memory, that big desk, is called DRAM. It's the big, affordable workspace. But then there's SRAM, which is the super fast, way more expensive, premium version. And because of its speed and cost, it's what we use for that tiny CPU cache we talked about earlier. It's really the difference between a big, general-purpose workbench and a small, specialized high-speed tool. So what happens when your desk gets too cluttered with too many open programs? Your computer does something pretty clever. It uses a little bit of your main storage, your hard drive or SSD, as virtual memory. But here's the huge catch. Grabbing something from that overflow storage is incredibly slow compared to grabbing it off the desk. You know that jarring pause you get when you switch between way too many open tabs? That's your computer swapping data, and it is a major performance killer. Okay, I know that's a whole lot of theory, but how does this stuff actually affect us in the real world? Let's look at a couple of real-world examples where these specs made all the difference between success and failure. Picture this, an entire major airline completely grinding to a halt. Flights are canceled, thousands of passengers are stranded. This actually happened in 2021. And the culprit? It wasn't some sophisticated cyber attack. It was overloaded servers with outdated CPUs and simply not enough memory to handle all the traffic. It was a multi-million-dollar catastrophe caused by a simple hardware bottleneck. Now for something a little more down-to-earth. A student built this amazing robot for a competition, but it just kept freezing up at the worst times. The problem wasn't the code, it was the hardware. The robot was running on a weak, single-core CPU with a tiny amount of RAM. A simple upgrade to a multi-core processor and more memory completely transformed it, turning a glitchy robot into a potential champion. That's the real, tangible impact of this stuff. So, what are the big takeaways here? First, your computer's performance is all about that delicate dance between the CPU and memory. Second, those 4 keys for the CPU, cores, clock speed, cache, and type, are what define its raw power. Third, that memory hierarchy determines just how fast the CPU can actually get the data it needs to do its job. And finally, understanding this balance isn't just for tech geeks, it's your superpower for fixing problems and making way smarter purchases. And all of this leads to the final and honestly the most important question of all. Now that you know the secrets behind the curtain, what specs matter most for your goals? Are you a gamer who needs to chase that high clock speed? A video editor who needs as many cores as you can get? Or maybe you just want a smooth, frustration-free experience every day? The next time you look at a spec sheet, you won't just see a bunch of confusing numbers, you'll see the potential.